What's up, guys? We're on our last episode of the recreating the solar system in Universe Sandbox. Today we'll be adding up the finishing touches, as well as the dwarf planets and maybe a couple of stuff. We're gonna start with Ceres in the middle of the asteroid belt. Why do I have Jupiter selected? Random small moon. Alright. Dwarf planet. Yeah, hold on. Is it around the same size as Ceres? Let's check. Yeah, it's around the same size as Ceres. Okay. There's Ceres is like a decently cratered surface. So we're gonna go to planetscaping and add elevation, radius down. But then we just throw this all over the planet. Oh wait, hold on. Remove. I don't use the planetscaping tool very much. Leave me alone. Alright, there we go. Also, there's gonna be like some ice. We add it. And then or like freeze. But yeah, Sirius has some ice. There we go. Alright, now we're going to the important stuff. Beyond the orbit of Neptune. We have a new dwarf planet. Nope. Nope, I don't know. Bye. Eccentricity is like 0.2. That's its eccentricity. And then it's at times it goes closer to the orbit than Neptune is. Alright, hold on. This might be. This is way bigger than Pluto's. Hold on. Pluto. Oh, never mind. It's like around the same size again. Alright, hold on. We're gonna try, like, adding the heart. So we're gonna have to change the base color, elevation. I might just see it on the map. But hold on. Map. Hold on. Why is it like gray? Hold on. Whatever. I don't know what to do. I don't know what to do with it. So yeah. There's Pluto. Now we get. Why is this moon so? Okay, hold on. Small moon. It's like would have like a decently eccentric orbit. That's Sharon. And now if we create the berry center, yeah, it should be outside of Pluto's surface, and it is barely though. We might have to make Sharon's mass slightly higher. Hold on. There we go. That's better. Anyways, Pluto has four others moons close, and they're like all asteroids. Okay, second is Styx being outside of Sharon orbit. It's gonna have like an asteroid further away from Pluto. And then more like and then we have Nyx being very close to Styx, but not that close. Kerberos being like a couple thousand kilometers further. And then we have Hydra. Also, hold on, let me bring Sharon's eccentricity down. We're bringing his eccentricity down. It'll help stabilize the other moon's orbits. Pluto has its own moon system now. It's really awkward. Now we have Haumea. Random moon. Okay, hold on. The defining feature of Haumea is not its moons, even though it has moons. Hold on. Composition. Freeze all. There we go. Its Haumea's incredibly fast spin time. Alright, we have Haumea's incredibly fast spin time. It's like flattened, basically. Hold on. Haumea also has rings. This is way bigger than Haumea, though. Wait, let me actually. Where's Haumea? Yeah, we need to make it smaller, pretty significantly smaller. Whoop. Yeah, it's a dwarf planet, guys. I have the flashlight on. Why is there dark spot? Okay, never mind. Yeah, now it's a similar size to Haumea, slightly bigger. Let's make it a little bit smaller. Okay. Hold on, it's not massive enough anymore to hold its mass. Wait, let's make it. Haumea's rotation is like 4 hours. Let's make it like accurate. Hold on. Dude, these particles are being kind of annoying. Now, Haumea and ring. Also has two incredibly small moons, like literal asteroids, just like Pluto's moons are. I'm pretty sure they lay within its ring orbit. Hayaka and Namaka and Hayaka. There we go. We're done with Haumea. Very long orbital periods. All of these are like closer to our to the star than they actually are, though. Like Uranus's orbit is 84 years, so it's like 4 times longer than this here now. Saturn's orbit is like 29 years. It's 6 years on this. Jupiter's orbit is 2 years. That's way shorter. Mars' orbit 9 months. That's insane. Earth's orbit, guys. Hold on. A season is only 2 months now. We don't have a 3 month winter. Winter. Yeah, we have a cool Earth with its own moon. Okay, we already have a sleep in our solar system, but we have another one now for some reason. All right, next up we have now I have Quorer. Okay, it's like it has an eccentric orbit though, so it might not be ideal. It has an eccentric orbit, pretty. Its orbit eccentricity is pretty decently high. That's because it gets closer to the sun than Haumea does sometimes. So we're gonna make it like 0.3. An accurate eccentricity would be further than like that. Yeah, that would be an accurate eccentricity. No, it wouldn't. Hold on. Definitely less than 0.3. Oh, I forgot to mention I need to put Pluto's orbital plane up. Hold on, it's not on the same orbital plane. Inclination is going. Hold on. Oh my god. It's like this. Okay. Time to delete its moons and then re-add them. I forgot to put Pluto on a separate orbital plane. That's kind of why it's still there. Delete. Delete. Okay, hold on. Its moons really should have come with it, otherwise I wouldn't. If they didn't, I wouldn't have had to delete that. If they did, I wouldn't have had to delete them and re-add them. Also, I'm pretty sure it's in the negative direction, but whatever. Great Barrier Center. Alright, inside Pluto's surface, we need to make it a little bit more massive. There we go. And then we really don't care about 6 Nyx, Kerberos, or Hydra, so we're adding those back. Alright, there we go. Anyways, quarter time. Wait, just added it. Hold on. That's on me. Nope, I'm an idiot. Yeah, these. This is why I split it into 3 parts. If I did this all in one part, we would be absolutely, like, cooked. It would be absolutely cooked. There we go. That's Core's orbit. Core has a moon, I think. It's way what, right? Okay, its radius is definitely too big, so we need core for size comparison. That I don't think that's even how you spell core. Where? Alright, QO. Core. Nope. Core. Alright, hold on. Here's core. It's way smaller than this. It's not an asteroid. It's a dwarf planet. So, where did that come from? Hold on. Yeah, okay, that's fine. Horror has a moon. It's way what? Dear Lord, stop it. Hmm. And it also has rings. Ring. Add. Where's the outer ring? There we go. Horus rings are actually unique because they're way outside of Horus roast limit, so kind of awkward. It's also on a different orbital plane. Alright, next up. We have Maki Maki, Orcus, Gong Gong, Eris, and then Sedna. So next up we have Maki Maki. Has a very similar orbit to Haumea. Maki Maki also has a small moon. Nobody. Maki Maki's also like by far the most boring one on this list. By far it's the most boring one on this list. Okay, hold on. We're gonna give its color like a slightly reddish color. Cause that's what its color looks like. Color custom. Like pale red. Like a pale red. It's the second brightest object in the Kuiper Belt. And by brightest I mean second most reflective. Anyways, it has one moon. But also we need to Maki Maki has some comparisons. Not okay. We can make it slightly smaller, but that's literally it. Yeah, okay, that's good. It has one small moon, MK2, orbiting it. That's cool. Next up, we have Orcus, which is smaller than Ceres, I believe. So we're making it a random small moon. I can make it slightly bigger. Hold on. It's a dwarf planet. Yeah, there we go. It has a small moon named Vanth. Orcus is kind of boring as well, though. Orcus is done. Oh no, oh no, hold on. Pause. That's not what I meant to do. Random asteroid. There we go. Okay, that was close. Next up, I believe we have Gong Gong, or is it Eris next? I think it's Gong Gong, but okay, they're very close together. Gong Gong is slightly closer, but it also has an incredibly eccentric orbit, meaning its apocenter can reach further than Eris. So we're going Gong Gong next. It's pretty much. It's pretty. It's decently far. 0.4. This is. This is an incredibly eccentric orbit. Okay, hold on. 0.4 might be a little too high. 0.1 is too low, though. 0.4 is too high. It's like setting eccentricity. That's too low. Actually, wait, no, this might be good. This might be good. Hold on. Hold on. This might be good. Make it a little bit, make the pericenter distance a little bit further. Make the pericenter a little bit further. Now unlock everything. And then we can make the eccentricity higher. Here. Then we make the apocenter further. Yeah, like this. There we go. That's a good orbit. It's like a reddish color as well. Not. It's like a dark, but it's not as reflective as Maki Maki is. So that's what we're doing. Like a darker red. Okay, now we have Eris, the Greek goddess of chaos. Eris can is on average further than Gong Gong is from the sun, but Gong Gong can be further. Also, we have to make Gong Gong slightly smaller. Hold on. There we go. We have to make Gong Gong's orbit more eccentric as well. Hold on. Again. There we go. That's just around like 67 AU. Unironically. Hold on. Semi-major axis is still supposed to be around 67 AU, but 60. We'll make it 65 AU. For this, we're gonna lock it, and then we're gonna make this like 80. Like that. Yeah, that. There we go. That's good. Alright. It's kind of fitting that we got something with things, because we have to freeze everything. Can't believe we got a moon with an atmosphere. We need to make it in water. We need to make it smaller, though. It's a dwarf planet. And also, we need to freeze everything. Freeze. Radius 8,000. I just froze the entire planet on one side. Hold on. Eris also has absolutely no atmosphere, so 0. I mean, literally it has no atmosphere, so 0. Atmosphere, go away. Okay, I can't completely remove it, but this is it for now, I guess. Has a small moon. Dysnomia. It's bigger than most of the other moons we've went through so far, though. So, we're still going. It is, I believe it's spherical in shape. hold on, I'm gonna pause. We're gonna make it way, way smaller though. It says flying into, hold on. Shrink the radius way down. It's basically an asteroid now, but it still has its spherical. No, it's not spherical. Hold on, I don't know why I did this. It's not spherical. It's smaller than Mimas, and Mimas is the smallest spherical object in our solar system. Hold on. What? There we go. We got it. In the end. Okay. We're taking a big break. What is this? Bye. Alright, hold on. Much, much, much further away. We have a dwarf planet with an incredibly eccentric orbit. You are way bigger than you actually are. Hold on. No, you are way smaller than that. There we go. Okay, I need to make you like. There we go. A normal spear. Sedna's actually pretty red. It's the second reddest object in the solar system. After Mars. Sedna's not like. Not that red. Hold on, it's like a light red. Sedna is like by far the furthest. By far the farthest. It's like. Okay, hold on. In terms of its orbit, it has the longest orbit of anything we've ever discovered in our solar system. No known moons. So technically, we're done. Because that's the last one I was doing. But, because I don't want to be boring, and I want to add an Easter egg, and also this video is kind of short compared to the other ones, we're adding a planet 9. You heard me. We're adding a planet 9. Its eccentricity is probably going to be high. Okay, nope, you don't. Done. Hold on. We start by adding ISIS to its composition. Because we didn't have ISIS for the rest of them, so we need to add a. It's gonna be like 40 mass of the Earth. There's ammonia and then there's methane. It's an ice giant. Meaning, okay, we don't know much about this. But we'd also assume that it's actually slightly less massive than Neptune is, so that is not correct. We'll make it like 12 times the we'll make it like 10 times more massive than Earth. That's how big. And then it would be small, and then it's thought to be smaller than Neptune in radius. Yes, and right now it's not, so. Whoop. Nope, that's not what I meant to do. We're locking the mass. Still, we're bringing the radius down to like triple. Smaller than Neptune in Uranus and radius. It's a mini Neptune. Or it's slightly smaller than them in radius. Hold on, let's make it a little bit smaller actually. Yeah. Meaning it's by far the densest gas giant now. It's more dense than Neptune is now. But this is how it's thought to be. And let's be real, it's probably around the same color as Uranus and Neptune. And if we go check them, it's like they're pale blue. They're like a pale blue. So we're making Planet 9 that color, but we're going to enhance it, making it slightly brighter blue like we did with the other ones, to make it look cooler and easier to see. Hold on. And better. But yeah, I am no stranger to designing ice giant colors correctly. It is a pale blue always because of the methane. These bands, contrast 1, contrast 0. Hold on. We'll make the contrast like 0.23. Yeah, we'll keep it like this. But this would be Planet 9. No. Simulated. Select object. Okay, hold on. How do I do this? It's not a binary, guys. Select. Alright, hold on. Just to solve this problem, I'm adding a minuscule asteroid. Don't. This is just. SEMA is now its orbital parent, alright? Select. There we go. Now you just don't check it. But now it's a planet. This is kind of cool now. We don't check this. Hold on. Now if I delete this, will this go back to being the binary or no? Yeah, it does. Hold on. Alright, hold on. This is just going to be far outside of the system. There we go. Lutura. That is the orbital parent. No one would go out this far. There we go. Now no one will distract the thing. Yeah, anyways, this is the entire solar system. I'm done with this. Now, we start with our sun. It's a solar system analog. It's not like a perfect solar system recreation. Followed by Mercury, heavily cratered. And then Venus. hot. Earth actually looks good with the moon. I'm pretty sure. Okay, I didn't cheat on the moon. I cheated on a lot of moons, but I didn't cheat on our moon. And then there's a lot of other stuff. I'm saving it now. Alright, we're done with the series. This is the last video. I'm gonna be making a Minecraft video soon. Soon when the sulfur caves come out. That's my next Minecraft video, guys. Save. Place. Alright, bye guys.